Before we graph the rational functions, here are some basic concepts that we need to keep in mind. The domain of a function is the set of all values that the variable x can take. The range of the functions is the set of values that f of x will take. The zeros of a function are the values of x which make the function 0. The real number zeros are also x-intercepts of the graph of the function. And the y-intercept is the function value when x equals 0. The vertical line x equals a is a vertical asymptote of a function f. If the graph of f either increases or decreases without bound as the x values approach a from the right or left. To find the vertical asymptotes of a rational function, number 1, find the values of a where the denominator is 0. Number 2, if this value of a does not make the numerator 0, then the line x equals a is the vertical asymptote. The horizontal line y equals b is the horizontal asymptote of the function f if f of x gets closer to b as x increases or decreases without bound. To find the horizontal asymptote of a rational function, determine the degree of the numerator and denominator. Let n be the degree of the numerator and m be the degree of the denominator. If n is less than m, the horizontal asymptote is y equals 0. If n is equal to m, the horizontal asymptote is y equals a divided by b, where a is the leading coefficient of the numerator and b is the leading coefficient of the denominator. An oblique or slant asymptote is a line that is neither vertical or horizontal. It occurs when the numerator of f of x has a degree that is 1 higher than the degree of the denominator. In symbol, if n is greater than m. To find slant asymptote, simply divide the numerator by the denominator by either using a long division or synthetic division. The oblique asymptote is the quotient with the remainder ignored and set equal to y. We will better understand this if we have an example. Number 1, find the domain, zeros, intercepts, and asymptotes of the function f of x equals x plus 1 divided by x minus 2. Letter A. Observe that the function f of x equals x plus 1 over x minus 2 is undefined at x equals 2. This means that x equals 2 is not part of the domain of f of x. In addition, other values of x will make the function defined. So the domain of f of x is the set of all elements of real numbers such that x is not equal to 2, or all the real numbers except 2. Letter B, a rational function will be zeros if its numerator is 0. Therefore, the zeros of rational functions are the zeros of each numerator. So x plus 1 equals 0, x is equal to negative 1. Therefore, x equals negative 1 is a zero of the function f of x. Letter C, recall that the x-intercepts of rational functions are the values of x that will make the function 0. Since the 0 of the function is x equals negative 1, it is also an x-intercept. The y-intercept of a function is equal to f of 0. In this case, f of 0 equals 0 plus 1 divided by 0 minus 2 equals 1 divided by negative 2, or f of 0 equals negative 1 half. D. The vertical asymptote is the value of x for which the denominator is 0. So x minus 2 equals 0, therefore x is equal to positive 2. The line x equals 2 is a vertical asymptote. Since the degree of the numerator is equal to the degree of the denominator, the horizontal asymptote is the quotient of the leading coefficient of the numerator and denominator. So y equals 1 over 1 equals 1. So the line y equals 1 is the horizontal asymptote. Now let us see the graph of f of x equals x plus 1 divided by x minus 2 using GeoGebra to check our work. This is our graph. We can see clearly that x equals 2 is not part of the domain of f of x. At the same time, the line x equals 2 is the vertical asymptote, while the line y equals 1 is the horizontal asymptote because the graph gets closer to these lines but never touches them. The zeros or the x-intercept of the function is at x equals negative 1, and the y-intercept is at y equals negative 1 half. That's all for now, guys. See you in our live discussions for more examples, graphs, and problem solving. See you guys. Stay safe, stay home, and stay productive. Bye-bye.